Alright, so today we're going to go over lesson 5.3, which is over solving linear systems by elimination. So this will be the third type that we've talked about in this chapter, about third different method of how to solve linear systems, systems of equations. So the first one we talked about was how to graph them and solve them. Then we talked about the method of substitution, and now we're talking about elimination. So the reason we discuss all three is it's good to, there's different scenarios where it'll be easier to use certain ones. So it's definitely good to have the different options in order to make it easier on you to solve these problems. So let's go ahead and jump into what the steps of elimination actually are. So number one, it says multiply, if necessary, one or both equations by a constant, so at least one pair of like terms has the same or opposite coefficient. A lot to break down in that. So first of all, multiply if necessary. Sometimes this won't have, sometimes you can skip step one, kind of like we could with substitution. Sometimes step one is already done and you're good. If not, multiply one or both equations by a constant. So you're going to multiply in a system. Usually in 8th grade we'll deal with, 8th or 9th grade we'll deal with just one equation in a system, or two equations in a system, not more than that. So we're going to be multiplying one or both equations by a constant, meaning you are multiplying one equation or both equations by a single number, and you get to pick what that number is, but you're multiplying the whole equation by that. So at least one pair of like terms meaning the x's or the y's, has the same or opposite coefficient. If we haven't discussed, or if you don't know, coefficient is the number in front of your variable. So you want either the same number or opposite numbers. For example, you would either want 3 and 3 or 3 and negative 3. You want those types of numbers because then that's where it gets you to being able to eliminate. Because then, step 2, you add or subtract the equations to eliminate one of the variables. So, obviously, if you have opposite coefficients, meaning 3 and negative 3, you would have to add the entire equation in order to eliminate those. And just the opposite, if you have the same coefficients, 3 and positive 3, you would need to subtract both equations in order to eliminate those. So anytime you have opposite coefficients, you add them. Same coefficients, you subtract them. You solve the resulting equation, which you should be able to do, and we'll talk about what that looks like. And then last step, substitute the value from step 3 into one of the original equations and solve for the other variable, which you should be familiar with after using substitution. So let's go ahead and jump into some examples. Here's our first one. We have the system 3x plus 2y equals 4, and 3x minus 2y equals negative 4. Okay, so again, start with step 1. It says multiply, if necessary, one or both equations to get opposite or the same coefficients. This one, we do not have to do that because our x's, and you only need it to be for one of them. You don't need both of them to be opposites or the same. You just need one, the x's to be the same or opposites, or the y's to be the same or opposite. Luckily, this is an example where actually both of them are, but again, we don't need both of them to be. 3 and 3 are the same, so those are the same coefficients. 2 and negative 2, those are opposite coefficients. So you actually have your choice here, whether you would like to eliminate your x's or your y's. Doesn't matter which one you do, because no matter which one you choose, it'll work out the same way. So we'll just eliminate the x's. So to eliminate x's, remember, if you have the same coefficient, you need to subtract the equations. So, when you subtract the equations, you are subtracting every part of that equation. So what I mean by that is 3x minus 3x, those cancel. Those are gone. But then you have to do all of it. 2y minus 2y is 4y. So you do that part. Bring down the equal sign, and then you also have to do the other side. 4 minus negative 4 is positive 8. So once you've eliminated one of the variables, you can just solve the resulting equation. Hence, step 3 from the last slide. So last step, we would divide by 4 on both equations, or both sides, sorry. And then y would equal 8 divided by 4 is 2. And then lastly, we need to get x because our answer will be as ordered pair form. So we take y equals 2 and plug that into one of our original equations. Doesn't matter which one. We'll just use that first one. 3x plus 2 instead of y, we plug in 2 equals 4. 3x plus 2 times 2 is 4, so bring that down. 3x plus 2 times 2, 2 times 2 is 4, so we're plugging in 4 for there. And then we're just going to solve. Subtract 4 from both sides. 3x equals 0. And then we divide by 3. So x equals 0. So your final answer in ordered pair form is your x first, 0, and then your y, 2. So your answer here will be the ordered pair 0, 2. So you just do those steps, get one of the variables, and then you plug it in to get the other variable. Okay, so let's look at another example, or let's have you try one on your own, see if we kind of understand what I am talking about with that. Okay, so on your own, try this. Pause the video, try it, and then we will discuss it together. Okay, so this will be more common of what you see, where you don't actually have the option of x or y to eliminate. There's just one that is obvious that can be eliminated, and then you eliminate it from there. So here, we have 3 and negative 3. Those coefficients are opposites, so we don't have to multiply anything here. We can just go ahead and eliminate. So what that looks like is, if we have opposite coefficients, to eliminate those, we need to add the equations. So we're going to add these equations. 3x and negative 3x, when added together, cancel out. 2y plus 4y, I'm getting ahead of myself, is 6y. And 7 plus 5 is 12. Okay, so once those are eliminated, then we can just solve. Divide both sides by 6. Y equals 2. So then we take that y equals 2 and plug it into one of the original equations. Again, either is fine. I'm just going to use the first one. 3x plus 2, and in place of y, we have 2 equals 7. So then we have 3x plus 4 equals 7. And we're just solving. Minus 4 on both sides. 3x equals 3. Last step, 3 and x are being multiplied together, so the opposite will be divide by 3. So x will equal 1. So your ordered pair for this system would be 1, 2. That is your answer for that. So those aren't too bad, especially whenever you don't have to multiply either of the equations. If you already have opposite or the same coefficients, you can just jump straight into eliminating. But let's get into examples where you might have to multiply one or both. So now we have the equations. Negative 10x plus 3y equals 1. And negative 5x minus 6y equals 23. Okay, so here we obviously see we do not have either variable with opposite or the same coefficients. So what you're going to have to do is multiply one or both to see if you can get either the x's to have the same or opposite, or the y's to have the same or opposite. So the first thing that catches my eye is the -10 and -5. I know that if I multiply -5 by 2, that will give me -10, and those will be the same coefficients. So that's the option I could use. Obviously, you could also do something with the y's, but either is fine. As long as you do the math correctly, it'll work out. So what I'm going to do is what I discussed first, is to multiply this whole equation by 2. So I bring over the same top equation, -10x plus 3y equals 1. And all I'm doing here is multiplying 2 by each part. And by each part, that means every part. So 2 times -5x is -10x. 2 times -6y is -12y. And 2 times 23 is 46. So now this is my new system that I'm using to eliminate. So now I do have coefficients that are the same or opposite. We have -10x and -10x. So remember, if they're the same, that is whenever you subtract in order to eliminate. So now we're subtracting the entire equations. So -10x minus -10x, those cancel. 3y minus -12y is 15y. And 1 minus 46 is -45. So once those are eliminated, this makes it a very easy problem. We divide both sides by 15. And we get y equals -3. So now we're going to take that and plug it in to one of our original equations. Again, I'll just use the top one. We have -10x plus 3. In place of y, I'm going to put -3 equals 1. So -10x minus 9 equals 1. And now we're just solving for x. Plus 9 plus 9. -10x equals 10. Divide both sides by -10. X equals -1. So our ordered pair for this one would be -1, -3. -1, -3. So that's an example where you have to multiply one of the equations by a constant to get one of the pairs of coefficients to be the same or opposite. And then from there you're solving and getting your x and y. So last thing, let's look at an example where you might have to multiply both of the equations by a constant in order to get an answer. So here we have 5x plus 2y equals 235, and 2x plus 3y equals 160. Okay, so here's an example where you won't be able to just multiply one of them by a constant because there's no number I can multiply this 2 by to get it to be 5. Like, you need it to be a whole number constant. You can't be like 2.5 or something like that because it makes it a lot harder. Same here. I can't multiply 2 by a whole number and get 3. So what I'm going to have to do is pick which variable or which coefficients I want to get the same or opposite, and then choose two numbers that I can multiply. I can pick a constant I can multiply this by and pick a constant I can multiply that by for them to be the same or opposite. So I'm going to, in this example, use the y's just because they're smaller numbers. Make the math a little easier. You can use the x's if you want. It doesn't matter. But for example, I know that 2 and 3 both go into 6. So what I'm going to do is I'm going to multiply each of them to get to the number 6. So what that means is I'll multiply this top one by 3, because 3 times 2 is 6, and then I'll multiply this bottom one by 2, because 2 times 3 is 6. So my new top equation will be 3 times, again, I'm multiplying that 3 by everything on the inside. 3 times 5x is 15x. 3 times 2y is 6y. And 3 times 235 would be, let's see real quick, that would be 705. Let me check my math on that real quick. 235. Yep, 705. Okay, so that is my new top equation. And in my bottom one, again, I'm going to take my constant and multiply it by each term. So we have 2 times 2x is 4x, 2 times 3y is 6y, and 2 times 160 is 320. So once I multiply both by a constant, I now have the same coefficient for my y's. So if I have the same coefficient, to eliminate them, I subtract. So then I'm just going to go part by part. 15x minus 4x is 11x. 6y and 6y cancel, so 11x equals 705 minus 320 is 385. Okay, so after that, we're going to divide both sides by 11. So then we'll have the 11's cancel out, and x will equal, again, if you don't have a calculator, you can just work this out on the side. When you work that out, you should get 35 for x. So x will equal 35. So if x equals 35, I have to take that, and I'm going to plug it back into one of the original equations. Not the ones that I multiplied, one of the original equations. So I'll just use this top one, 5x plus 2y equals 235. So 5x, but in place of x, I'm putting 35. So 5 times 35 plus 2y equals 235. 5 times 35 would be 175 plus 2y equals 235. Now we're solving for y by opposite operations. Subtract 175 from both sides. We'll get 2y equals 60. Then last step, we divide by 2. Y will equal 30. So x equals 35, y equals 30. So our final answer would be 35, 30 as an ordered pair. So that's probably the most difficult elimination problem you'll have, where you have to multiply both. But still, if you just organize your thoughts, you should be okay doing that. So again, the steps for the elimination is, first, see if you need to multiply. If you have a opposite or same coefficient already, you don't have to. If you don't, you need to multiply one or both of those equations to get one set of those coefficients to be the same or opposite. And then you'll add or subtract. Again, if you have these same coefficients, you need to subtract to eliminate them. If you have opposite coefficients, you need to add them to eliminate them. Then you're just solving from there, which is pretty simple. You just have to get the x or the y by itself, whichever it is. And then once you solve for one of the variables, you plug that back in to get the other variable. Thanks.